So as we review for your test, there's 3 that I'd like to make sure you remember. Things like this where they're asking you about, you got 3 choices for this and 4 choices for that, and they're so easy, you just multiply. If you had 3 choices of socks and 2 choices of shoes, you'd have 6. 3 times 2 is 6. 6 choices total. Okay, that or 6 combinations. All right, so I showed you that. I had red socks. These are the socks. I had red, blue, and yellow socks, and I had shoes that are white or green. That way I get different letters. I could either have red with the white, or I could have blue with the white, or I could have yellow with the white, or I could have red with the green, or blue with the green, or yellow with the green, and that's all the combos there are. And instead of having to think of all of them, you go 3 times 2. That's it. Okay, next up is sometimes we give these questions about, a lot of times it's license plates because they just work really nice. If we had numbers for this and letters for this, let's imagine it's a safe combination. And there's letters, a couple of letters, a couple of numbers, and you want yours to be AL52 because your favorite player on Alabama is number 52, then you know that that's your combo, and there's only one of those out of how many total could there be? 26 times 26 times 10 times 10. Because why? Because these are choices. Got 10 choices for number and 26 choices for letters. So the probability somebody would guess your combo will be 1, because that's what they want, is to figure out yours. Over all the possibles, you'd multiply this times this times this times this. All right, so if there's blanks, what am I doing again? I'm multiplying choices. You multiply it all the way across. But why do we sometimes go 26 times 25? And then 10 times 9? You remember that kind? Because you can't repeat them. Good. Because if there's 26 letters and you already picked one, now you got only 25 letters to pick from. So if we ever make it go down one, like 26, 25, 10, 9, that means you can't repeat things. All right, let's see if you really got that. Let's say you're setting the safe, and you decide that your only choices on your safe, because it's a cheap hotel safe, is there's 5 letters to pick from and 10 numbers, and it's a number, or it's a letter, and 3-digit number. How many different combos would there be? And I'm going to say no repeats. Again, it's all about just multiplying your choices. You take your headphone out, sir. My headphone out. I have to get mine in. I wear them a lot myself. Okay. What does this 5-letter thing mean? Well, it's because you could only pick from 5 letters, because it's this little like spinny dial thing, and they only have 5 letters on there you can pick from. So how many choices do you have? 5. And then how many choices do you have for this first digit? 10. How about the next digit? 9, and then 8. Raise your hand if you had that one right. Okay, cool. Any questions about those kind? Do you get the repeating thing? If I could repeat them, I would have 10 choices for all 3 slots. Does that make sense to you? I could take any of the 10 numbers, and I could have like the number 777 would be an okay number to have. But if I can't repeat them, and heck, if I picked 7 for my first number, now I have less choices for my next one. Okay, so that's the blanks and multiplying choices. How about just plain old drawing a card out of a deck of cards? Well, if there's 52 cards and you have one card you want, like you want the ace of spades, then there's a 1 in 52 chance you're going to get it. Okay, so if it's a deck of cards kind of question, it's usually something like this. But what if you would be thrilled with any ace? Well, we'd have to give you a list because we understand not all of you are card players. Those of you that are card players probably know there's 4 aces, and you'd have a 4 in 52 chance. Okay? But what if you took out that card and you didn't replace it? Now you want to get another ace. Can you finish this problem? This is the first ace. and this is another ace. And remember, any probability that's a fraction, this is what I want. I wanted the 4 aces. And this is what's possible. There's 52 cards in the deck. To get another ace, Hunter Comp, what do you say for this spot? 3, because we already got an ace back here. So there's less aces in there. Times 51, or out of 51, very good, because, not because of the whole repeating thing, but because we already took a card out, so there isn't 52 left in the deck. Now there's only 51 that are possible. So once again, this is what I want, which is the 3 aces that are left out of what's possible. All right, so card problems are usually like that. Next kind is area, like what's the probability we'd land inside of this? I don't want to do that one because I'm going to ask you to do it in a second. But I just want to make sure you know the basic formulas. Do you remember the area for a triangle? It's let's make it a 4 for a base and a 5 for a height. What's the area of this?
I think you multiply 4 and 5 and you just like divide it by 2.
You are correct. All right, how about for this circle here? And don't say it out loud this time. Just hold that thought for a second and write down what you think the area of that circle is if it has a radius of 2. And then there was this one weird shape called the trapezoid. If this is 3 and this is 5, with a height of 2, what's the area of that? 3 kinds of shapes you got to know areas of. But otherwise, you're just going to take the area on the top divided by the area on the bottom. So for this one, just like Kyle said, you just do 5 times 4 and then you divide it by 2. Or you could times it by a half, which is the same thing as divide by 2. So this would be 20 divided by 2, which would be 10. The area of this one is pi r squared, and the r in this case is 2. So that's 2 squared is 4, and 4 times pi. And I think most of you will know that pi is 3.14. You can always ask if you want on the test. This one, average the bases. Don't use 3, it's too small for the base. Don't use 5, it's too big. 5 would be giving you this area of this whole shape right there. So we don't use 3 and we don't use 5, so we use the average of them, which is add them together and divide by 2. The average is 4. Say average of the bases times the height. 4 times 2, 8. Did anybody have 8 before I said it? Okay. Now, I'm going to give you one like this then. This is 10. This is 12. Right away, I'm averaging them. I don't know if you are. And the height of this thing is, let's see if that's probably about 5. And let's say that this length right here is 4. That'll give us a nice triangle we just did a second ago. What's the probability of landing inside there? All I need you to do is set it up, and it's always what you want over what's possible. I want the little triangle. Figure that area, put it here. What's possible is that bigger trapezoid shape. I made the numbers easy enough, so I think you can do them all in your head. Liam, have you figured out how to do, I know you know the triangle part. That's too easy. I'm not even going to ask you. 5 times 4 is 20, divided by 2 is 10. But how about the other one, the bigger area?
Do you want the answer?
How to do it? How do you get the area of the big blue trapezoid thing?
You average base on these 2 and multiply by height.
What's the average of 10 and 12? Very good. 11 times the 5, final answer? 55 is correct. 10 out of 55. That's the probability of hitting that little triangle. That makes sense so far? Okay. Now, what's the other way we could do it? Well, the rest of the shape, and the way I say it is this. You already know it's out of 55, right? And so if I want the probability of hitting anywhere in this yellow shaded region, it's pretty much 55 out of 55. Except not that part. How much was that part? What's the area of that little triangle? 10. Do you get how that worked? It is almost 55 out of 55 because it's almost the whole thing. You're very likely to hit in that yellow area. But you got to take away the area that we don't want to hit. So instead of 10 out of 55, is 55 minus the 10 out of 55. All right. Next kind is, let's say there was righties and lefties in the room, and people that had dogs and people that had cats and people that had none. I'm not going to ask you for your opinions like on what your situation is. I'm just going to give you some numbers that are really easy. 1, 2, 3, 4, 1, 1. And then you do not have to write all these down. What you're going to have to do is answer some questions about it. 2 plus 1 is 3, 3 plus 1 is 4. If I add straight down, 1 plus 2 plus 3 is 6. This adds up to 6. And they add up to 12 in both directions. Cool. So let's say this represented you guys. There was only 12 people in the room. What's the probability that I get a right-handed person? I think these are the easiest kind because you can look up right-handed people and eventually you'll figure out that there's 6 of them. But it's a probability, so then you got to divide by something, right? Divided by 12. Do you get in this scenario? There's a 6 in 12 chance that you are going to have a right-handed person. That's a 50-50 chance. That's called odds, though. We don't say 50-50. We could say 0.5. All right. Now, the way harder kind is, and let's see if you remember this, given left, that means I'm only going to talk to the lefties. What's the probability they have a cat? Try this without my help. It's just 2 numbers divided. I hope it's easy for you. But this is called conditional probability, and it's definitely a step up over just the probability of a right-handed person. All right. Given lefty meant, I think it's the best thing to do is just circle this because it'll remind you those are the only numbers now. As soon as I said given lefties, the rest of the numbers are gone. All I can use is 4, 1, 1, and 6. Okay? So given that, the probability of cat, the only cat number left is 1. It's that one right there. 1 out of, how many is possible? Well, you can't use that number because we can only use these numbers, so it's 1 out of 6. Who had 1 out of 6 before I said? Awesome. That kind's, I think, fairly easy. And then the last kind, Venn diagrams. Let's say I had a 4 and a 2 and a 3, and this is dogs, cats, and neither. It's going to be a decent number of neithers in this scenario. If I asked you, how many people did I talk to? Could you figure that out? Who got 14? Who had 14? Am I right? I think it's 14. Yeah, you just add them all up. It's out of 14. Okay, so then what's the probability that if I grab a random person that I'm going to get a cat person? They have cats, or a cat. I should just say cat, just in case it's not plural. Maybe they just have one cat. Oh, it's so common for people to say 3 out of, and the total was 14. I like to put the total here. This is not a requirement, but I like to have the total somewhere. And it's so common to say 3 out of 14 because I go, cats, there's the cat number. Wrong. It's actually what? 5. Because you got to include both of these because they both have cats. And I know people are like, but they have dogs too. The question is just, do you have a cat? That's what this is. Probability of cat. You ask these people, do you have a cat? No. Do you have a cat? Yes. Do you have a cat? Yes. So then it's 5. Those 3 and the 2 together. All right. Now here's the harder kind. Given that a person does not have a cat. No, that doesn't mean they have a dog. All it says is given not cat. What's the probability of dog? Given not cat. Well, when they say not cat, I would scribble out the cat numbers to keep you from by accident using one. And now I only got 2 numbers, the 4 and the 5. What do I want? Dog. And the only number left that goes with dog is 4. Out of 5? No. 4 out of what? 9. Because all the possible people we could pick would be 9 people. All right. There is a quick overview. That's what the test is like. I didn't cover every absolute thing, but I covered almost everything. And now what I want to do is have you work with a partner to answer about 6 questions together to make sure you got this, and then there's somebody else right there checking you. So for that, would you please open the thing called Probability Review Notes. I'm not giving you all of those to do right now. I don't think you need to do all of them. You could, but I don't think you need to. So here's the ones I think would be smart to do. Number 1's too easy. Number 2. Number 3. Number 6. 2, 3, 6. Possible. And this is the first part of your homework, is to do this. Then there's a Schoology quiz, which we will start together after everybody has had a chance to work on these with a partner. So again, you've crossed off number 1. You've crossed off number 4. All you have to do is 2 and 3. You crossed off 5. You're doing 6. And then the ones on the back page. All right, so I would ask that these 2 rows slide over next to each other. These 2 rows slide over next to each other. All right, so here we go. Start with number 2. Just talk it through. And I pull up my calculator on my iPad to just like finish these off quick. Okay, so I'm going to start even if you're not done. Just finish up while I'm doing this because it'll take me a minute, and you've probably already done with the first ones, right? So, license plate has 4 digits. Ooh, 1, 2, 3, 4 blanks. That's how you do that. And you got to put choices in there. Followed by 2 letters. Do. And the first digit cannot be a 0. Oh, well then there isn't 10 choices. There's 9. And the first letter must be a B. Oh, well then there's only 1 choice right there. But there's 26 choices of letters for the rest of it. All right, then can they repeat? If it doesn't say anything, then there's no rule against repeating. In the real world, numbers repeat all the time. So I used to live at 2112, 2112. That's a lot of repeats going on. 2112, what was it again? Spruce Place. That's where that's where I grew up. Okay, so there's repeats unless they say otherwise. So then I can repeat these numbers. And that means this could be 10 choices, this could be 10 choices, and this could be 10 choices. So again, if it doesn't say, then there's no rules, which means it can repeat. All right, next up, a bag has 4 green marbles, 6 blue, 3 yellow, and 5 white. I should have been adding them up as I go. 4 and 6 is 10, and 3 is 13, and 5 is 18 marbles. That's always important what it's out of, right? What's the probability that the marble that John draws is neither blue nor white? So in other words, he really said it's not blue, it's not white, then it must be green or yellow. And there's 4 and 3 makes 7 of those. So what I want is those 7. 7 out of 18. Raise your hand if you had 7 out of 18. Okay, good. Next up, this one. So what you want and what's possible are always key. So I put them like this. You don't have to, but I think it's smart. And I also think it's smart to start with the bottom, which is the biggest shape that there is, which is the great big, well, it says the length and the width are 8 and 8, so that's probably this and this, right? Okay. And so then it must be 64 on the bottom. Now, is this the kind where I just want the circle on top? No. If I just wanted the circle, it'd be pi r squared right now, and the radius is 4, and so you'd say 4 squared. I personally would just put 16 right here, but if you allowed 4 squared, that's okay. But this would be wrong. This would be the probability of hitting the circle. What I want is not the circle, so not the circle means you subtract the circle. So it's this kind, 64 minus that. There's the setup. If you did the setup right, you would have got the answer right, as long as you can type on a calculator. All right, can you remove the headphone again? Thank you. All right, so any questions about that one? The reason it wasn't just pi r squared on top is because we didn't want to hit the circle. We wanted to hit the rest of the shape. All right, moving on to the next page. Seven, 8, and 9. And just making this thing is going to take a minute. Ooh, I want to talk about that for a second. Go to this last set of problems about this Venn diagram. Here's where people mess up. They go 36 like blue, 36. No, all of those together, this and this and this and this, have to add up to 36. So you put the 36, you can do this right now, right by the blue. That means all of them together make 36. Same thing for the white. It's not 38 right here, it's 38 here, because all 4 blanks add up to 38. And then here's another chance to mess that up. 15 liked red and blue, and then half the time kids are just like, ooh, I found it, red and blue right there, 15. Nope, that's not 15. Because these 2 spots together make 15. So that's why it's hard to do these, because you can't just stick the numbers onto the chart. You gotta like use logic at the end. I will tell you what the key always is. The thing in the middle. So if we know the thing in the middle, 5 liked red, white, and blue. As soon as we know that's 5, then right away things start falling into place. Because now that 15 makes sense, because this plus the 5 makes 15, and then you'll know what goes there, and do it like that. So I got you started on that problem. And cross off the very last one too. Cross off number 14. All right, so these, I'm thinking this is 10 minutes maybe. I think that's of these. The probability of randomly chosen student, oh, that means it could be anybody. See, it's out of 120 right there. 120 possible. Chose math as their favorite subject. Well, I can't just pick these people. They liked math, but these are all the people that liked math. So I go with 32 out of 120. All right, what's the probability a randomly chosen student chose McDonald's? Oh, just as easy, 60 out of 120. And who likes math, oh wait, probability that a student who likes math, ooh, notice they are saying that it's only out of math liking kids. That's what they're saying with that. So I'm picking only from the math kids. That's these guys. And that narrows it down to out of 32. And now it's Subway the most. The thing I want is Subway, 3 out of 32. I know they never said the word given, but that's what they meant. All right. Then we go down to the Venn diagram here. And I tried to prevent the most common mistake was to just slap 15 right there. But 15 isn't right, but 10 is. And then this one, 17 liked white and blue. That's 17 total right there, but you can't write 17 right there, but you could write 12 there because 12 and 5 together would make 17. Then 19 liked red and white. That's these two. 19 total would mean 14 go here. And then 40 liked red. I haven't put that on here yet. Oh, that's the key. Because as soon as I can do this one, because they have to add up to 40, then 15, 25, 29. So this makes this 11, because that has to add up to 40. This one has to add up to 38. So then that's 26 and 5 makes 31, plus another 7 would make 38. And then this one has to add up to 36, that blue circle. And we already have 27, so then that would be 9. Now, how do we figure out this last empty spot? Well, we know the grand total is 73. I'm putting it here. So I have to go and add all of those other numbers. It's a bit of a pain. I'm going to grab my phone because I find it's fastest to just be able to read the problem to the AI. What is 9 plus 12 plus 7 plus 10 plus 5 plus 14 plus 11?
9 plus 12 plus 7 plus 10
68.
plus 5 plus 14 plus 11 is 68.
So if that's 68 and I want it to add up to 73, I'm going to do 73 minus 68. And I think I can do that in my head. Did you guys get 5 for that? I think it's 5?
Yeah.
Okay. All right. That right there, probably the hardest question on the test because you have to get like 7 little tiny adding problems right to do this right. Now that I've got the numbers, it shouldn't be hard to answer the actual questions. How many students do not like any of the 3 colors? Well, the not, that's right here. That's 5. How many students do not like red? Well, I'm going to say these are the ones who do like red. And I'm going to take away those from 73. What is 73 minus 10 minus 5 minus 14 minus 11? It's 33. Can anybody verify 33 for that answer? All right, good. And I get you, if you got any of these numbers wrong, then you're not going to be getting, 11, 12, and 13 right. So, all right. What's the probability of a student liking exactly 2 colors? Well, you ask these kids one at a time. Do you like exactly 2 colors? No, they don't. Do these 12 here, do they like exactly 2 colors? Yes, they do. Okay, so that's 12 kids so far. How about the middle ones? No, the middle ones, the 5 here, they like 3 colors. They don't count. It's only 12 and 14 and 10. So 12 plus 14 plus 10. And that adds up to 36. All right. Other than making a dumb mistake in the adding part, how many of you feel like you understand these Venn diagram problems? Be honest here, I need to know, because otherwise we may need to practice it more. Do you feel like you understand the Venn diagrams? All right. All right, then I think it's a small enough number that you could just ask me during work time. So now, what we're going to do is start that. Okay, wait. Dropbox what you just did. Get free points. Super easy. I just wanted to have a reason that you'd want to get that done. So, we're done with it already. Dropbox it. The Dropbox is already there. Next is a Schoology quiz. And I'm gonna open that up right now. I didn't want it open earlier, because frankly, I didn't want you to be distracted looking at that, while I was hoping you would do the first part of the homework. All right, so now I'm opening up a PDF that's called Probability Review Schoology Questions. So these are the Schoology, this is the Schoology part of the homework. I will start it with you to try to keep it from being too long, but today is the most important night of the week. We're getting ready for that big test. There are only 6 questions, but granted, there's multiple parts. So. All right, so number 1. Everybody got the questions open? I don't want you to have the Schoology quiz out yet, because too many things open might mean less likely to do it. All right, so I'm trying to open it so that I can have both my iPads working right now. And I have found the wrong thing. Hold on. Here we are on Monday. There it is. Okay. Question 1. So you got a bag with diamonds around the opening filled with Hot Wheels cars. There are blah, 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 a whole bunch of different things in there. What's the probability you're going to pull out a Shelby Cobra? All right, well, what you want is the Shelby Cobra. 2 would seem like it's the right answer, except that's not a probability. 2 out of, has anybody added them all up yet?
30.
I agree. It is 30. I can verify that. So then it's 2 out of 30. Now, it does say your answers may be fractions, decimals, or percents. Now, I think we all know that 2/30 is 1/15. That's what I would put in just in case it's required that they be reduced fractions. So there's your first Schoology answer. We're going to put it in a minute, but let's finish up the second question. What's the probability you do not pick a fire truck or tractor? Well, then you got to figure out what you do want. We do not want fire truck. I'm going to cross it out. And we do not want farm tractor. Then that's 13 of them that we don't want. There was 30 total. And there's 30 that I would want, except taking away the 13 I don't want. And that would lead me to, I think it's 17. Can anybody verify 17? Yep, I'm seeing people nodding. 17 out of 30. All right, so we got our first answers. Now it's time. I'm going to open up the Schoology quiz, and you can drop that answer in there. So if you refresh in about 10 seconds. Settings. Oh, it is enabled already. Yep. All right, so it's there. You should be able to put that in. I'm double checking that the answers I told you are actually the correct answers. Wait a minute. Was I doing fire truck and all that stuff? Was that the wrong one for the Schoology quiz? Does the Schoology quiz not match the worksheet? It appears to not match the worksheet. Okay. Oh, that's interesting. All right, we are going to pull the plug on this review. We're gonna do the Schoology quiz instead. So, I'm sorry, but I'm gonna just unpublish that And I'm gonna leave the Schoology quiz in there, because I know those questions are good. And I'm gonna double check what I could remove out of the Schoology quiz to make it more reasonable in length. I could take that one out. Okay, so just open the Schoology quiz and we will start that in a second. I'm removing question 2. If you already did it, it won't hurt you. Okay, good. So here we go. Number 1. You have a bag of Starburst. There's 5 pink, 3 yellow, 2 orange, and 4 red. What's the probability of not picking red? Well, I'm going to add them all up. 5, 6, 7, 8, 9, 10, 14 total. And I want not red. So you could just add up all the things that are not red, and that probably is just as fast. It adds up to 10. Or you could have done 14 minus the 4, which would still be 10. So your first answer is actually 10/14, but I think since we all know 10, 14 are both even, we should simplify that to 5/7. So there's your first answer. I have double checked it. It is correct. Okay, so you and the kid next to you have the exact same problems. Why don't you just work through the first one together, see if you guys get the same answers for problem number 1. And from there, you just have this for practicing for tomorrow's test. And I really think it's going to be a great way to do it. Remember that you get the answers at the end after your first try, and you'll see what it should have been. If you get any wrong, please take a minute, look at what the right answer was, and try to learn from that. Tomorrow morning is a Tuesday, so that means if you want extra help, it's the perfect time. You could come in the morning. If you don't get probability, come in and get some extra help. And I will hopefully see some of you tomorrow morning. And your only homework is, from here, is that Schoology quiz. That's all I got for you for today.